Hi guys, greetings of the day. I Vijay Tawardhan welcome you to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also, click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 12. In session number 12, we are going to discuss the following, out of which the first one is called as fixed displacement pump and method of achieving variable displacement. Now, basically, what is called as fixed displacement? The mathematical formula for theoretical volumetric displacement of a Vane pump is given by this expression, which we have seen in the previous session, that is Vd is equal to pi by 2 into dc plus dr into width of the rotor into eccentricity of the rotor, where dc and dr are the diameter of the cam and diameter of the rotor, and where this can be expressed in terms of k into E is equal to Vd, where k is nothing but pi by 4 dc plus dr into W is going to be the constant, where K is the Vane pump constant for a given pump, what we have discussed right now. Now, it can be observed from the relation that the theoretical volumetric displacement Vd is going to be a function of the diameter of the cam ring and the rotor and the width of the vane and also the eccentricity. For a given size of a pump, the diameter of the cam, diameter of the rotor, and the width of the wheel are going to be fixed, and that is why they are all constants. Then, for any variations in volumetric discharge is to be the variation of the eccentricity. As the E varies from 0, that is when the center of the rotations of both the rotor and the cam ring coincide, that is E is going to be maximum when the rotor touches the inner surface of the ring, that is when E varies from 0 to E max, and hence the volume displacement of the pump. If it is not possible to vary the eccentricity, then the volume displacement of such pumps remains constant or fixed, and hence such pumps are also called as fixed displacement pumps. Now, coming to variable displacement pumps, variable displacement in vane pumps can be achieved by changing the geometrical position of the cam ring relative to the rotor, which changes the eccentricity and hence the displacement. You can observe the same thing or the technique as shown in the figure. Now, this figure shows one of the methods adopted to achieve variable displacement in vane pump. The main parts of this pump are the cam ring, rotor, vanes and screw position for the adjustment of the cam ring. What you can observe over here. Okay, just a minute, let me switch on the pointer so that explanation become easier. Okay, now by operating the screw, the geometrical position of the cam ring with the center of the rotation of the rotor can be varied. Sorry for this. Now, you can see the next figure, which shows the three different positions of the cam ring. Of course, only two, and this two, and this is the one. These three figures, with respect to the center of the rotor, that is, when E is positive, that is E is equal to E max, then the discharge Q will be the maximum. And when E is equal to 0, no discharge, and when E is negative, E is equal to E max, then the discharge is maximum and the flow is in reverse direction, which you can observe the things very carefully. Now, the variation of the eccentricity influences the theoretical volumetric displacement of the vane pump. And now, you can see the next figure over here, that is, you can observe this linear displacement, which shows the displacement eccentricity characteristics of a variable displacement pump, where Vd is equal to 0, E is equal to 0, and Ed is equal to Vd is equal to maximum when dr minus dc by 2. That is what in one of the previous session what we have discussed. Henceforth, the displacement eccentricity characteristic of variable pumps, you can see as the eccentricity increases, the volumetric discharge increases. Now, the proportionate pressure variation inside the unbalanced vane pump you can observe this. Now, before that, let us understand what is called as unbalanced vane pump. A vane pump during its operation experiences two different pressures. A low pressure at the inlet side of the chamber and a high pressure at the outlet side of the chamber. And this creates the undesirable side loading on the rotor shaft resulting in damage to the intricate parts of the pump. And the unbalanced forces of loading reduces the service life of the pump. This is about the unbalanced type of pumps what you can understand. Now, what is called as balanced type of pumps? The concept of balanced vane pumps you can observe here. Unbalanced just now in the previous session we have discussed, that is previous slide. Now, what is called as balanced vane pump? The problem of unbalanced loading on the shaft in the vane pump can be overcome by replacing the circular camring with an elliptical camring as shown in the figure what you can observe here. Instead of circular, we can put it in the elliptical camering. What is the advantage? As the camering assembly of the assembly of camering and the concept of working of a balanced vane are shown in this figure here. In this case, the rotor concentrically placed with the elliptical camering. This creates two inlet and two outlet chambers such that two high pressure quadrants oppose each other and the two inlet chambers are directly opposite to each other. Thus, the forces acting on the shaft are fully balanced and the side load of the unbalancing is completely eliminated. In actual design, the two inlet ports are connected to a common inlet, and similarly, the two outlet ports are connected to a common outlet, which is as shown in the figure over here on the right hand side. Then coming to the more understanding, you can observe the figure over here. That is balancing and reversing of the wheel pump, which is a self-explanatory, what we have discussed right now. Then one more type of vane pump that we are going to discuss is called as pressure compensated vane pump. In certain hydraulic system, it is desired that the pump should stop pumping when a set or a predetermined pressure is going to be reached. Now you can see the figure. This is possible by using a pressure compensated vane pump. In this case, the system pressure acts directly on the camring on the right side as shown in this figure. These forces the camering against the compensatory spring-loaded piston on the left of the camering. When the discharge pressure of the pump is large enough, it overcomes the spring forces and moves the camering to the left. You can observe the same thing in the figure over here. This results in the reduction of the eccentricity, and this reduction is maximum when the discharge pressure is zero. As the discharge pressure continues to increase, zero eccentricity is finally achieved and the pump flow becomes zero. Such pump has its own protection against the excessive pressure which is going to be built up, and you can see that in the figure over here, which shows the pressure versus flow characteristics of a pressure compensated vane pump. Then coming to the vane pump characteristics, one of it is called as cutoff pressure. What is called as cutoff pressure? It is the discharge pressure of the pump which is equal to the compensatory spring pressure force denoted by P cutoff, and the deadhead pressure which is called as it is the maximum discharge pressure of the pump at which the compensatory spring is compressed at zero eccentricity is achieved and at which the point flow ceases. Now the vane pumps are moderate to high in overall efficiency and power rating. A good vane pump may have a volumetric efficiency as high as 90%. Now you can see the characteristics of the vane pump which is given in the figure over here. By this, the time allotted for the session has been exceeded. Henceforth, I am going to stop at this location. Now, thanks for your patience listening to the session. And if you have any sort of doubts, feel free to use the comment section for the further discussion. and I am going to answer all your questions related to the topics covered in this particular session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Bye bye. Have a great day.